Okay, good afternoon. Let's continue on our lectures. Can you hear me?
Yes, teacher.
Okay. But before moving the today's lecture, first of all, I would like to mention about the coursework for this semester that you have to complete. And the coursework is uploaded into the team space. If you go to the Teams and NM 16.1 and 2-2 general channel, in files sector, sorry, production technology 2 channel, files, there you will find a coursework for students. Please download it and start working on it. It's the same workload, work frame. You go from chapter to chapter in the coursework and work out the problems or answer the questions in this coursework, and then depending on how we go on this matter, we will decide is it to be submitted by online or a printed version to the department. Okay. In case of online submission, please submit the PDF as a one document. Last semester, I had cases when people digitalized or the page by page and sent to me 37 page of pictures or PDF files. So please compile it into one PDF file and send it to me. Okay. In case of electronic submission, the first thing, download it and start working on it. Okay. Next, is that clear? Any questions about coursework? Hello?
Hello, Ilhan teacher.
Yes.
Yes.
I have a question. What's the deadline of the coursework?
Deadline of the coursework is the end of the semester time, and I think it's 8th of January.
Okay, sometime.
Okay. Then there were some questions about topic 1, and I'd like to answer those questions, like about multi-phase flow in the horizontal section of well. Let me share. And I believe, can you see the slide?
Not yet.
Yes.
We see. Yes.
So I believe it's about this table, the multi-phase flow in horizontal section of well. So what is it about? So it's about Okay, if we have this kind of undulation in the wellbore, so what happens wellbore, depending on the fluid characteristics, fluid composition, so inclination downward like this is tending the liquids trapped in this area, in this downward or this, let's say, syncline area, because it is heavier than the gas, and vice versa in the inclination upward or, let's say, anticline area, the gas may be trapped. And this will cause, first of all, some, to some degree, not totally, of course, obstruction on the fluid flow, as well as it will cause the separated flow of gas and liquid, which is called slug flow, when the portion of gas goes through the tubing and then portion of liquid, which creates instability in the tubing in the wellbore, which causes unstable wellhead pressure. And in case of artificial lift, as you know, many artificial lift types, well, all of them actually, except the gas lift, are very sensitive to gas production, gas component in the liquid, and therefore they will be quite a problematic for this artificial lift. Okay, and so it's the same if we have a deep and peak. So when it is perfectly horizontal, we may have here stratified wavy lines like a in horizontal tubes at the surface, going. So the gas will be flowing at the top, and the liquid will be flowing at the bottom, and that may cause some, again, slugging, and at very high rates, because at very high rates this stratifying or segregation will cause high rates will cause wavy lines, and wavy flow will cause, again, the separating gas portions and liquid portions, creating some slugging effect again. Okay, so therefore it is desired to have of course, this perfectly horizontal is the kind of the aim, or little bit downward inclination is the aim, but that kind of undulations, when you have wellbore like a going up and down, is always problematic, again, as I said, because of trapped liquids, trapped gas, slug flow, which is unstable, which creates instability, and therefore those undulations are not desirable. And from that we come to the point that geological steering is very important. The next question was the desirable to steer well just under the shale that seals the reservoir. and the question is why. The reason, because when we have shale here, this is a ceiling formation, and we have no fluid or in this to flow into the wellbore. And keeping this well in this horizontal direction, away from the water at the bottom, will prolong the water-free production. Okay. The gas in the reservoir will go through to the top of the reservoir, and you may ask, or you may think that this will be case when the wellbore will be fueled by gas. Well, first of all, this is another issue, another question to the reservoir engineering rather than the well performance, or especially horizontal well performance. So we have to maintain the wellhead pressure, the reservoir pressure, and we have to produce the well at conditions that are favorable for the fluid production. And also the horizontal well is the main one of the main objectives or aims to drill and exploit the oil field with or gas field with the horizontal well is horizontal well allows to produce same or even higher amount of hydrocarbons with lower drawdown. And lower drawdown means lower pressure depletion. And in any case, the pressure maintenance is again one of the major reservoir management issues. So it has to be followed. So here we follow the well performance issue, which is in this case, if we don't have a gas cap, if we have a shale at the top of the reservoir, on the above the reservoir, which is a ceiling, then it is better to keep away as far as possible from the water, oil-water contact, to avoid or to delay the water breakthrough into these horizontal wellbore. Because if taking into account some possible heterogeneity, lateral heterogeneity in the reservoir, if the if the water breaks at any point of the wellbore, then unless it is a smart completion, when we can isolate zonal production or zonal inflow from each zone by the packers and ICV, ICD devices, this whole wellbore will be damaged. Damaged, I mean, if we, for example, if the water breaks through at this point, then all this portion of this horizontal section, we have to shut off this water part, and production of from this part will be again cut off, or will be even less, because we have to first of all we have to stop the production, do water shut off, and water shut off is not easy in normal, especially open hole wells, or even perforated wells, because in horizontal case, if the water comes here and you shut off this in this part, then this water will go through, because it's lateral and horizontal flow, this water will be spreaded into the other direction, and it will easily reach the wellbore again. So you have to do this water shutoff in the other zones, and this water shutoff means at this zone the more zones are cut off from the inflow from the production. And the last question was horizontal well and horizontal well completion expressions. Well, it is, in most cases, it is the same thing. Depending on what are you considering. If you are considering completion issues or well construction issues, it might be called horizontal well completion, meaning any completion type or any completion issues. And if you consider a well performance issues like production from the well, the management of the well, it might be just horizontal well as well. So it is essentially the same thing, but depending on what method you are considering or in which context you are using, it might be specific to completion or just well performance or well issues. Okay. So for that, the question that was the last question to consider. If you have any other question, if you think that you didn't get the answers completely, please ask now or later. It doesn't matter. So if you don't have questions now, I will move to today's lecture.
Thanks. I got my questions.
Okay.
Answer my questions.
I'm trying to share. Okay. Let's see. Okay. Can you see the slide now? Deformation damage?
Not yet. Yes.
Yes, I see.
Okay. So last time we started with deformation damage, and we learned what is deformation damage as a one component of well skin. The general major results, how it kind of results in the reservoir by the blocking the pore throats or pore space in the formation by reducing the absolute permeability and changing wettability, so reducing the relative permeability, and solutions like a matrix simulation, hydraulic fracturing, or advanced perforation technologies to bypass the formation damage. We listed mechanisms of the formation damage to understand. We will consider all those type of mechanisms later in more details. So what are the working mechanism for each, and we consider it what is skin in the wellbore, what the effect of skin, what are the composition of skin, components of skin. We talked about the geometry skin, the completion skin, the production skin, and formation damage skin. So the modeling of the formation damage with the skin is given here, and it's taken from the Michael Economidis book of petroleum production systems. Here you can see the formula or equation, Hawkins equation, that is used to calculate the skin, and this is how we derive this formula when for the non-damaged steady state pressure drop, we have the formula that comes out, the Darcy's law, and if we have, and here you can see the permeability is the original permeability of the reservoir or formation. And for the near wellbore damaged zone, we have the reduced or damaged or affected permeability. In many cases, it is positive damage, or reducing damage when we call it positive skin. So, and that is here it is taken into account by adding this portion to this portion, like here. And when we get this equation for the delta P or pressure drop for this skin, then we get this subtraction, and the result of this subtraction, if we rearrange this equation for skin, for S, we will get this formula when we when the skin is equal to ratio of non-damaged or original permeability of the reservoir by the over the damaged or altered permeability minus 1 and multiply it by the normal logarithm of the damaged or altered permeability radius by the wellbore radius. Okay, so that's the Hawkins equation, and that's used to calculate, to estimate the skin, and it also can be used to estimate or evaluate the depending on what the task or what the what data is given. For example, if the well test from the well test data you have a original permeability and the altered permeability, then you can calculate the radius of altered permeability zone, because RW is known to you, or you can calculate original permeability if you have a skin value and altered permeability in near wellbore zone. So that's usage of this Hawkins formula. And here another kind of application of damaged skin, estimation of damaged skin on the well-bore effect. So as you can see, for different ratios of K original permeability over damaged permeability, we have a skin values and the depending on the radius of the formation damage. So what this is about, if the damage is high, like a original permeability ratio over the damaged permeability, sorry, over the 20, then as we go away from the well-bore, well-bore, so as the radius of formation damage increases, we get higher and higher damage. For the lower ratio, for the lower ratio of damage, the skin value, even at the further radius, at the longer radius, stays lower, although it's increasing, but at lower pace or lower velocity, lower rate. Okay, so the severe the damage, and the longer the radius, the higher the skin. Okay. Another approach or another estimation of this damage on the well-bore productivity is that if this is the productivity of the well, and these are different various curves for different here, just remember that here we have a damaged and initial, the ratio of damaged to initial permeability. So the lower this number, the worse the worst case. Okay, so this is the worst case when we have 20 time or 200 time change in the permeability, reduction in the permeability. So what does it mean? It means if with the lower, if the permeability of the near wellbore zone is half of that of the whole reservoir, then the productivity of the well will be damaged depending on the, again, depth of damage up to the 85%, sorry, 15%. Okay, but if the damage is as severe as damaged permeability ratio over initial permeability of 0.02 value, then the damage will be very severe, like only 25% of the total or ideal productivity will be seen, and this decline in the productivity will be very sharp. So even at very low damage zone or very small damaged radius cases, we will have up to 30 or even 50% the damage. And if this damage goes beyond the 1 inch, then we get very low, up to the 25% productivity. Okay, so again, the severe the damage, the more effect on the productivity. It is almost the same as the previous chart, but here you can see the in the skin expression. Here you can see it in the productivity expression. So generally, yeah, if the ideal no damage case, just to comparison for comparison, if the well rate at 0 skin, ideal with no damage, is 20,000 barrels, then skin of 2 will decrease it to 16, and skin of 8 will decrease it twice. Okay, and the higher the skin, the higher the effect on, the higher the more the increasing damage, the higher the skin, and the higher the effect on the production. For in cases when we get positive skin, like from stimulation or well deviation or hydraulic fracturing or whatever reason, we increase the permeability or around the wellbore or increase the effective wellbore radius, we can get negative skin, and this negative skin will affect the productivity like a if we get, for example, -6 skin, then we may get 80,000 barrels per day, so increasing the productivity. By the way, the negative skin cannot be more than 7 or 7.5 value, but the positive skin can be it's not limited, depending on the damage you make to the wellbore, near wellbore zone. Okay, here it's a comparison of the effect of damage on the well productivity that you have seen already in different form, and to the effect of stimulation on undamaged well. What you can see here, as we go away from the wellbore, effect of the damage, the more damage, the more effect at the to the productivity. Okay, and if we consider, for example, damage having 1 feet damaged radius, you can see that effect of the damage increasing from 20% skin to the 80%. Well, it is not skin, but the damage to the permeability, or 20% decreased reduced permeability to 80% reduced permeability, then we can see very big effect. So from around 97, 98 productivity ratio, it goes to the, if we consider 1 foot altered zone depth, it will be a 60% approximately 60% the productivity. But if we consider effect on the of the simulation, so for the same 1 foot stimulation, if we increase from 20 to 80, the increase will be only 10% or even less. And if we increase permeability by twice, then we may get 100, maybe 10 or 12% increase in the productivity. Okay, so that means the damage, the same amount of damage affecting the well productivity much more than the same amount stimulation. Okay. Apparently I don't have slide number 11. Do you mean this slide? Sujan. Slide 10. This one?
The one before this. Yes. This one, 10.
Before or after? This one?
Yes, number 10.
So it's again, it's the same as this one, but not in the productivity, but skin expression. So on the y-axis, we have a skin due to the formation damage. And on the x-axis, we have a formation damage, the radius of formation damage. And radius of formation damage or radius of damage is counted from the wellbore. Not the center of wellbore, but the wellbore itself. So if we consider it, well, it's shown here. Let me show here. You can see this is the wellbore. Okay, this is not the center of well, but the wellbore. Center of well is here somewhere. Okay, or the zero line. So the zero line is the center of wellbore or center of wellbore radius. Okay, so this is the wellbore radius, and the radius of damage is now considered from this wellbore and on or further. Okay, so what it says at the most severe case, let's say the damaged zone permeability is 20 times less than the original permeability, which is this yellow line. What we have a very substantial or very drastic change in the skin, or vice versa in well productivity. If we so as we go off the wellbore, as the radius of damage is increasing, so it says that this ratio is valid, for example, in this case for half meter. In this case is 1 meter. So at the 1 meter distance or from the wellbore, we have damaged or reduced permeability that is 20 times less than the original reservoir permeability. And in this case, skin is about 43 for this case. Okay. But if we have the reduced permeability less than, when the reduced permeability is less than the original permeability by 2 times, or the half of the original permeability, then the change as we go off the as we go further the wellbore, or as the damage radius increasing, the increase in the skin is not that severe that in the higher damage cases. Okay, so the severe damage, the more effect as the radius increases. Okay.
Yes,
So
I got your point.
Okay, so here it's the most important thing is the severity of damage, how much the permeability is damaged or reduced, and then the damage that is caused, sorry, the radius of the damage when we see the how long this damage is distributed in the wellbore. Okay.
Okay, thank you.
Okay, so again, as we talked from the beginning, from the last semester, when we were considering the near wellbore performance or wellbore well performance, the near wellbore zone is very critical. It is really critical because, again, first of all, the damage happened there, and also when we consider the reservoir fluid flow from the edge of the reservoir towards the wellbore, and wellbore diameter is very small comparing to the reservoir radius or drainage radius, then you can imagine that this flow path is very getting through reducing areas, because if we go from the edge of the reservoir, when we go through the edge of the reservoir, if this is the wellbore, what happens, the area that the fluid goes through to reach the wellbore and enter the wellbore is the cylinder of the cylinder area of the cylinder or prism that we have at each radius. Okay, and as you can see, as the fluid goes towards the moves towards the wellbore, this area is decreasing. But remember that the fluid that flow from the mass conservation law, the fluid that started to flow into this from this edge towards the wellbore should be is the constant. Okay, so therefore, as it goes through this radiuses, through this distance, the resistance to this flow is more and more. And even without, you can see here, even without damage, we have more substantial pressure drop in the near wellbore than through all the reservoir part. And if there is a damage in near wellbore zone, then this might be much severe, and it might be even stopping from the production, or as you can see from this chart, the severe damage at different depths may cause even 75% or 80% reduction in the well productivity. That means if we, at ideal case, we produce, let's say, 1,000 barrels. In this case, we will be able only produce at 250 barrels. And that is quite a damage and quite a reduction in the productivity. To compensate this loss, we have to, in this case, if we don't do anything with the near wellbore damage, we have to increase drawdown. Then increased drawdown will cause further damage, like sand production, like water breakthrough, instability in rock, etc., etc., etc. Okay, the gas dissolution in near wellbore zone, which again will cause relative permeability change. Again, another reduction in the production. So therefore, the formation damage is very important issue to consider, and it's very important issue to deal with great care and with great kind of thoughtful approach. Okay. So for today, we come to the end of the time for this today lecture. Any questions so far on this, what we have went through?
Ilham Melim,
yes.
Good afternoon. I actually wanted to ask one question, and I wouldn't tell that it is that much related to this topic. Okay. So we were reading some kind of material, and we encountered one article that was talking about some kind of nanoparticles. We use them for EOR purposes, and we may, to some extent, understand the particles that are changing the wettability from, let's say, oil to water. But why one would alter the wettability of the reservoir from water wet to oil wet? With which purpose it can be done? I mean, it's kind of risky, and in which circumstances one can make such kind of decision?
Changing from oil, water to oil? Or
yes, from water wet to oil.
From, actually, changing wettability from oil to from water to oil is considered as a kind of damage, because changing wettability, this might be only a positive effect, only maybe relative permeability, but again, it's questionable. I haven't gone deep in nanoparticles effect, but changing from it only maybe to increase sweep efficiency as a but still I have to look into that. Okay, I don't have a straight answer right now.
Okay.
If you give me this paper, I can go through and give more kind of sensible answer.
Okay, I will try to find and share it.
Okay, thank you.
Thank you.
Any more questions? Let's continue to tomorrow then. Tomorrow we'll continue on this formation damage, and we'll try to go further. We are moving very slowly. What else? Yeah, okay. Just be very kind of pay attention to the coursework, because it must be submitted before the 8th of January, before the end of semester. So you have a lot of deadlines this semester. So please download it and start working now to complete it in time. Okay. Again, you have to go from the chapter to chapter as you go through the material, but you have covered already a few chapters, so I think you should be able to start working on that, and as we go through the material, you will be able to consider even more chapters of the coursework. Okay? Thanks for your attention. If you don't have any questions, I will leave this meeting now, because I have another one a little bit later. Okay?
Okay, thank you, teacher. See you.
Thank you. See you.
Sağ olun Erkan müəllim.
Sağ ol. Sağ ol.
Sağ ol.
Goodbye, teacher.
Sağ ol.